Okay, so this is the first video to the SAT math section tutorial. And so if you're wondering where to start, this is it. The SAT is broken up into 3 sections: the Heart of Algebra, Data Analysis, and Passport to Advanced Math. Heart of Algebra is the first part you encounter, and it's usually the easiest for most students. And the next few videos, including this one, will cover we'll cover this section. Okay, so Heart of Algebra involves a lot of linear functions. So first we're going to start off by kind of defining a function, and there's 3 main ways in the SAT that they express a function. And it can be with a set of ordered pairs, so like we'll explain why that's not. I put a 0 originally. We'll explain why that's not a function in a second. Can be expressed through a set of ordered pairs. It can be expressed in an equation like this. That's an example of a really simple way to express an equation. And lastly, in the SAT, they'll express the function through a graph. So if you had a graph with a linear function going through it, this is one way to express a function. And so the reason originally I put 0, 1 and 0, 2, and the reason why I erased it is because notice that they both ordered pairs had the same x value, right? Both were zeros. So let's say if I had this instead as my set of ordered pairs. 2 x values are the same, therefore this set of ordered pairs cannot represent a function. That's just the rule they follow. And we'll explain why in a second. So to determine whether a function exists, one really popular way, like one of the main ways they do this is through the vertical line test. So if you have a function, like let's say this one. Let's take this one. If you're given a graph, the vertical line test is just if you were to draw a bunch of vertical lines, would these vertical lines ever intersect the graph twice? So we have this vertical line intersects once, and once. So no matter how many vertical lines I draw, it'll never intersect this line twice. So this passes the vertical line test, meaning it is a function. So that's why this would not represent a function. So if I were to draw these coordinates, 0, 1 is right about here somewhere. 0, 1 is right about here. And 0, 2 is right about here. So that would cause a straight line. Straight vertical line. So if I were to draw a vertical line, it would pass through an infinite amount of times. So more than once. That's why this will not pass the vertical line test. So if you're given a set of coordinate pairs and 2 coordinates have the same x value, you know immediately it can't represent a function. Let's go through an example. So, which does not represent a function? So which of these graphs does not represent a function? And obviously, it's going to be this one. I drew vertical lines right here, crosses twice. Once here, and once here. So this is not a function. Now A, you might think, taking a look at it, you might think it's not a function either. But this is something called a hole. We will probably cover this a little more later. But it's called a hole. And so technically it only crosses at one point. Alright, so let's take a look at function notation. So if I have f of x minus 3 equals x minus 3 squared, the reason why we write f of x instead of y equals, so the reason why we write it like this is just so, like, let's say if the SAT gave you two equations, instead of saying y equals twice, they say f of x, and maybe for the second equation they say like this, g of x equals, let's make up another function, 2x minus 1. So here are your two functions. So if the SAT asks you to find f of 5, so if the SAT wants you to find f of 5, which you do, now since it's f of 5, you know you're going to deal with this equation, not g of x. You're going to look at f of x. And set x equal to 5. So it's going to look like, so I'm going to take the original equation, I'm going to plug 5 in for x, anywhere I see x. So I'm going to plug in 5 there, minus 3 squared. So 5 minus 3 is 2, 2 squared, 4. So f of 5 equals 4. Now that I showed you this bit of information, I want you to find the following. Yeah. Okay. So find f of negative 1, find g of negative 1, and find f of g of negative 1. And if you don't know how to do this last one, that's okay. I'll go over this in a second, but pause the video and try to do these first two, and whenever you're out of ideas, resume the video. So, for this first one, f of negative 1, so we're now going to deal with this equation, because it's f of x. So, just take negative 1 and plug it in anywhere you see x. So you're going to have negative 1 minus 3 squared. Negative 1 minus 3 is negative 4. Negative 4 squared is positive 16. Okay, so f of negative 1, 16. G of negative 1, we're now going to deal with this equation, g of x. So let's take g of x and plug in negative 1 for anywhere we see x. So for this, I'm going to plug in negative 1. Minus 1. Okay. So 2 times negative 1 is negative 2, minus 1, negative 3. Alright, so g of negative 1 is negative 3. Now let's take a look at this last one. So the way this works is, it's not that hard, just you kind of like start in the inside and work your way out. So start by finding g of 1, which actually we did right here, is negative 3. So actually here, for example's sake, I'm going to change it a little bit. Let's say if I changed that to a 2. So first, working inside g of 2. So we're going to start by taking g of x and plug in 2 for anywhere we see x. Two times 2 is 4. 4 minus 1, 3. So g of 2 is positive 3. Now that we found g of 2, we find f of 3. So kind of think of it as g of 2 equals 3. So take that and kind of sub it in right there. So you'll be left with, it's really small, f of 3. So now take f of x and plug in 3 for anywhere you see x. So 3 minus 3 is 0. 0 squared is still 0. So f of g of 2 is equal to 0. And 0. Alright, and let's do one last example, and that will be, nope, let's do, yeah, just one last example. Alright, so if f of x equals a times x over b, and g of x equals cx squared over a, find g of f of a. So just like this looks a little different, but it's nothing we haven't talked about. So just like the last example, start with the inside and work your way out. So first, using f of x, find f of a. Plug in a for anywhere you see x, and treat a and b as if like they were variables. Go ahead and try it, pause the video, and whenever you're out of ideas, just resume. So, the way this is done, just like I said, start with the inside, f of a. So, take f of x and plug in a anywhere you see x. So I took that x and plugged in another a. A times a, again, treat it like a variable, so that will be a squared, just like x times x. When you're multiplying two things with the same base, and you just add the exponents. So that's why that's x times x would be x squared. So just like that, a times a would be a squared as well. So f of a is a squared over b. And notice there is an answer choice. So, but we're not done yet. So don't don't jump the gun, whatever the term is, and don't let it fool you. So this will always be an answer choice, but just know you're not done yet. You still got to find g of f of a. So take f of a and which is a squared over b, and now find g of a squared over b. So take g of x, which is over here, and plug in a squared over b anywhere you see x. So doing so, I got c times a squared over b squared divided by a. And it looks really messy, and that's not any of our answer choices. So let's try to clean it up as much as we can. First, let's go ahead and deal with this squared. So if we have a squared over b, just multiply the exponent with the exponents inside. It says that's a 1. This is going to be a to the power of 4 over b squared. Now, taking that back and multiplying it with c, and just like any multiplication of fractions, top times top, bottom times bottom, I just wrote c over 1 just to make it. So it's going to be c times a to the power of 4 over b squared. Now keep in mind, we still haven't done anything with a yet. So this is all over a. So we have a fraction divided by a number. And just like you learned, like, I don't know, back in middle school, the whole keep, change, flip thing of dividing fractions. So keep c times a to the power of 4 over b squared. Keep, change to multiplication, and flip 1 over a. And now go ahead and multiply. C times a to the power of 4 times 1 is just c times a to the power of 4. And b squared times a is b squared times a. Now this a and one of the 4 a's up here can cancel. So it's going to become c times a cubed over b squared. And let's see, that's it right there. That's our answer choice. And if you've got any questions on this last part you're not clear about, just leave them in the comments. Maybe I'll get to them. That's it for this video. And next video, of course, we're going to go more into linear functions.